Math 111 comprises of two main parts, which are the analytic geometry part and the calculus 1 part. The analytic geometry part focuses on conic section, which includes the circle, the parabola, the ellipse, and the hyperbola. In these slides, we are going to give an introduction to conic sections, and then we'll focus on the circle. Conic sections are obtained as an intersection between a double cone and a plane. If the plane is parallel to the generator of the cone, the cross-section is a parabola. If the plane is perpendicular to the axis of the cone, the cross-section is a circle. If the plane is oblique to the axis of the cone, the cross-section is an ellipse. And finally, if the plane is parallel to the axis of the cone, the cross-section will be a hyperbola. In our course, we are going to study the equations of these conic sections and the way to sketch them. Now, where do you find conics in your real life? In the Ferris wheel, this is a rotating circle. Also, satellites revolve around the Earth in elliptic orbits. The cross-sections of cooling towers is a hyperbola. This is the elliptic satellite dish, where the cross-section is a parabola. This is the M of the McDonald's. It consists of two parabolas. The roller coasters consist of parabolas, and it can be found also in architecture. And this is among many others. So what's the equation of a circle? We all know that if P is a point on the circumference of a circle and its center is given by h and k, then this distance is always constant and is equal to the circle radius. To calculate the equation of a circle, we just have to remember that distance formula, which is the distance between any 2 points. The distance between any 2 points is given by the square root of the difference between the x coordinates of both points squared plus the difference between the y coordinates of the 2 points squared. So the distance between any point on the circumference of a circle and the center, which is equal to the radius, can be given by the radius is equal to the square root of the difference between the x's squared plus the difference between the y squared under the square root. And if we square both sides, we'll get r squared is equal to x minus h all squared plus y minus k all squared. This is called the center radius form of the equation of a circle. As an example, we are required to find the center and radius for each of the following circles. In the first example, we are given x minus 3 all squared plus y plus 1 all squared is equal to 16. And if we compare it to the center radius form of the equation of the circle, we can easily see that its center is 3 and negative 1, and the radius is square root of 16. In the second example, it can be seen as x minus 0 all squared plus y minus 2 all squared is equal to plus 9. So the center is 0 and 2, and the radius is the square root of 9, which is 3. In the last example, it's easy to see that the radius is 0. So this is the equation of a point with coordinates negative 2 and negative 1. Or it can be seen as a circle with the radius is equal to 0. One more example. Now it's required to find the equation of a circle that's centered at 2 and negative 7, and it has a radius of 5. It's always advised that we have a sketch of the problem at first. Then, if we remember the center radius form of the equation, we can write it as x minus 2 all squared plus y plus 7 all squared is equal to the radius squared, which is 25, and then we can expand the equation and add like terms together. We'll have another example where it's required to find the equation of a circle with center 2 and 4 and the circle passes through the point 3 and 7. First of all, we have to make a sketch of the problem. We can see that the center is given, but the radius is not given. So we have to calculate the radius at first. The radius is calculated using the distance formula at the distance between these 2 points. So it will be the square root of 3 minus 2 all squared plus 7 minus 4 all squared, which is square root of 10. Then we'll apply the center radius formula. The equation of the circle will be given as x minus 2 all squared plus y minus 4 all squared equal to the radius squared, which is 10. One more example. It's required to find the equation of the circle whose diameter endpoints are given by A equals -3 and 4 and B 4 and 3. Start by sketching the problem. These are the endpoints of the diameter. It can be easily seen that the center is the midpoint of this segment, and the radius can be calculated at the distance from the center to the point B or from the center to the point A. We would start by calculating the center as the midpoint of the segment AB, which is equal to the sum of the x's over 2 and the sum of y's over 2. Then we'll calculate the radius at the distance between the center and the point B. Finally, the equation of the circle will be given using the center radius form. Now, if you want to go the other way around, if you are given the equation of the circle in an expanded form and we want to find its center and radius, we have to compare it to the center radius form of the equation of the circle, and we want to find the h, k, and r. To be able to do this, we can see the x minus h as a complete perfect square and the y minus k as a complete perfect square. So all what we have to do now is to make a complete perfect square with respect to x and make a complete perfect square with respect to y. As a reminder, how do we make a complete perfect square? If we have x squared plus or minus ax plus b, just keep the b as it is, and we add a over 2 all squared and subtract a over 2 all squared. This amount will be a complete perfect square, and we can write it as x plus or minus a over 2 all squared minus a over 2 all squared plus b. And then the a over 2 all squared plus b will add up. To apply this on the given equation, we rearrange the terms. So we'll have the x squared plus 6x and then y squared minus 4y next to each other, and keep the 12 on the right hand side. Then we'll make a complete perfect square with respect to x and a complete perfect square with respect to y. We'll have x plus 3 all squared, which is half the coefficient of x, and then subtract 3 squared, which is 9, and for these terms we'll add half the coefficient of y. It will be y minus 2 all squared minus 4, which is 2 squared, is equal to 12. And then we rearrange the terms again so that x plus 3 all squared plus y plus minus 2 all squared is equal to 12 plus 4 plus 9, which is 25. Now we can read the center and radius easily. The center is -3 and 2, and the radius is the square root of 25, which is 5. And this is the required circle. This is our last example, and it is required to calculate the equation of the tangent and normal lines to the given circle at the point 4 and 2. First, start by making a sketch. This circle has a center 1 and -2, and the point 4 and 2 lies on the circumference of the circle. Because when we substituted with 4 and 2 in the equation of the circle, we got 25, which is equal to the right-hand side. Then, to get the tangent at 4 and 2, this is a point that lies on the circle. All what we have to do is to make a derivative of the equation of the circle and then substitute with 4 and 2. This will give us the slope of this line. So we'll make a derivative of the equation of the circle. It can be dealt with as an implicit differentiation. We'll get 2 multiplied by x minus 1 plus 2 multiplied by y plus 2 multiplied by y prime. Then we'll get y prime in one side and then substitute with 4 and 2. This is the slope of the tangent. Finally, you can get the equation of the tangent as y minus 2 over x minus 4 is equal to the slope of the tangent, and then we'll make cross multiplication to get the equation of the tangent. Then, to get the equation of the normal, which is the red line, these two lines are perpendicular to each other, so the product of their slopes is -1. So if we know the slope of the tangent as -3 over 4, then we know the slope of the red line as 4 over 3. And we can get then the equation of the red line, knowing its slope and the point on it. So it will be y minus 2 over x minus 4 is equal to the slope of the known.